Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In the last video, we saw an example on how normal distribution can be used as an approximation to Poisson distribution. Today again in this video, we will see another example on the same concept. But before we start, a small request. After watching this video, if you find that the video was useful, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with today's question. This question is from May-June 2014, paper variant 71, question number 8. Let's see what the question says. The first part says that the following table show probability distributions for the random variables v and w. So they have given some table here for random variables v and w. For each of these variables v and w, state how you can tell from its probability distribution that it doesn't have a Poisson distribution. So that means both random variables v and w do not have Poisson distribution, and we are supposed to identify that with the help of these tables. So what we have learned? We have learned that any random variable which follows a Poisson distribution basically has got whole number values. Why whole number values? Because the random variable represents the number of occurrences of that particular event, which is represented by that particular random variable. Correct? So any random variable which is following a Poisson distribution cannot take values which are negative, cannot take values which are not integers, not positive integers in fact. Okay, it can take only whole numbers, that is from 0 and positive values, positive integers. So can we say that variables of any Poisson distribution can take only whole numbers as values? Only whole number as values, correct? So if we talk about the variable v here, the variable v is taking a value -1. Can it take a value -1? No. Okay, it's a negative value, so it cannot take. So can I say for variable v, it cannot take negative value? Correct? And what about variable w here? What is a variable? Variable w. If you see, variable w is taking a value which is not an integer, not a positive integer here. Okay, it is taking a decimal value which it cannot take. That means it cannot take non-integer value. Correct? So looking at the distribution itself, we can say that both V and W don't follow Poisson distribution. This answers the first part of the question. Let's go to the second part. What they are saying, the random variable X has a Poisson distribution with the parameter lambda. It is given that when X takes a value 0, the probability is equal to P, and when X takes a value 1, the probability is equal to 2.5 P, where P is some constant value. And they are telling us to show that lambda is equal to 2.5. And then they are telling us to find out probability of X when X is greater than or equal to 3. Okay, this we can find out when we get our lambda. So first of all, we need to prove that lambda is equal to 2.5. So how we are going to prove that? Here, because X follows the Poisson distribution with the parameter lambda, okay, then can I say probability of X is equal to 0 is equal to what? E raised to minus lambda into lambda raised to 0 upon 0 factorial, and this value they have given it as P, correct? So from this, can I say that E raised to minus lambda is equal to P? Why? Because lambda raised to 0 is 1 and 0 factorial is also 1. So can I say E raised to minus lambda is equal to P, and in turn I'll write down that this is equation number 1. What else they have given? They are saying that probability of X is equal to 1 when X is equal to 1 is 2.5 P. So probability of X equal to 1, if I have to find out using the definition and or the formula of the Poisson distribution, what I'll get? I'll get this as E raised to minus lambda into lambda raised to 1 upon 1 factorial, and this value is equal to what? 2.5 P, correct? So from this, can I say E raised to minus lambda into lambda is equal to 2.5 P? Okay, so I have got what? Two conditions, and I have got from these two conditions two equations. So if I use these two equations, if I try to solve, what do I get? In place of E raised to minus lambda, can I put P here? Yes, I can put P here. So what I'll get? So from first and second, can I say P into lambda is equal to 2.5 P? So can I cancel P from both the sides? Because P is a constant here. Okay, I can cancel that particular value. And what I'll get in turn is lambda is equal to 2.5. I've shown this particular thing as an answer. So this answers the first part of question number 2. Now they are asking to find out probability of X greater than or equal to 3. So let's do that. So the B part is what? Probability of X greater than or equal to 3. They are telling us to find out. So we have already studied in earlier videos that probability of X greater than or equal to 3 will be what? It will be 1 minus probability of X less than 3, which in turn I can say it's nothing but 1 minus probability of X less than or equal to 2, correct? So can I say this is nothing but 1 minus E raised to minus lambda. What is lambda here now? 2.5 into, I'll find out the probability of X equal to 0, X equal to 1 and X equal to 2, and I'll add up all the probabilities here. Can I say this is like this? 1 minus probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2, correct? And for this particular three probabilities, I can take E raised to minus 2.5 outside. So inside what I'll get? For probability of X equal to 0, I'll get 1. Then probability of X equal to 1, what I'll get? I'll get this as lambda, that is 2.5, plus for probability of X equal to 2, I'll get it as 2.5 square upon 2 factorial, correct? And 2 factorial is nothing but 2. Okay. So if I solve this whole thing and I subtract it from 1, what value do I get? I get it as 0.456, correct up to 3SF. Okay. So this answers the part B of the question 2. Let's go to question 3. What they are saying? The random variable y as a distribution, Poisson distribution with the parameter mu here, not lambda but mu, where mu is greater than 30. Using a suitable approximating distribution, it is found that probability of y greater than 40 is 0.5793, correct to 4 decimal places. And they are saying find the value of mu. So we are supposed to get that mu ka value. We don't have enough space here. Let's go to the next page. So what they have given here, here they are saying that y is following a Poisson distribution, correct? With the parameter mu. And they are saying that mu is greater than 30. Where mu is greater than 30. But since mu is greater than 30, we can approximate this Poisson distribution by normal distribution. Yes or no? So we can say since your average rate or the average rate of occurrence or the mean is greater than 30, therefore y which is following a Poisson distribution can be approximated by normal distribution. Can be approximated by normal distribution. Correct? And what type of normal distribution? Where y follows normal distribution with what parameters? Parameter here, the mean and the variance both will be equal to the mean of the Poisson distribution. So that is mu and mu only. Correct? Where I can say mu is nothing but mu. Let me write this properly. And variance is also here as mu. Correct? Now what else they have given? They have given that probability of y greater than 40 is 0.5793. They have given probability of y greater than 40 is 0.5793. But this is when y was following a Poisson distribution. But since we are trying to approximate it by normal distribution, okay, we will have to take into account the continuity correction. So let's work out the continuity correction here. So this is when y is equal to 40. When we are applying, we will have to apply continuity correction. So we will think about add 0.5 or subtract 0.5 depending upon the scenario what is required here. So here y is greater than 40. So that means 40 is not to be included and we have to move to the right of 40. Correct? So that means with continuity correction applied, we have to take y ka value as 40.5. Okay? So we can say probability of y greater than 40, which was for the Poisson distribution, gets transforms to probability of y greater than 40.5. Okay, when we are applying normal distribution. Now this is a normal distribution, but when we use the normal distribution table, we use the standard normal distribution table. So we will have to convert this into a standard normal distribution form. So can I say this is probability of z greater than 40.5 minus mu is here mu only, divide by square root of sigma square, correct? So square root of sigma square means square root of mu here. And they have told that this probability is equal to 0.5793. So that means this probability has to be equal to 0.5793, or in turn this probability has to be equal to 0.5793, correct? 0.5793. If you look closely, this probability here 0.5793 is greater than 0.5, correct? That's the most important thing. It is greater than 0.5. So what does this indicate? Let's try to understand this with the help of a curve. So suppose this is the normal distribution curve for y. Okay. So here y, if it is given and I say y follows the normal distribution with the parameters mu comma mu here. So here the mean value will be what? Mu. Mean value is mu, and they are saying that this probability is greater than 0.5. Greater than 0.5 means what? We know that it's because this total area under this curve represents a probability value equal to 1, and this curve is symmetrical on either side. Okay, so that means this area here to the right, will have a probability 0.5, and the area to the left here also will have probability equal to 0.5, but required probability is greater than 0.5. So because required probability is greater than 0.5 and we have to move to the right, so that means they are saying that my y ka value basically has to be less than mu, because we are targeting this particular area, the area which is to the right of that y ka value. Okay, so that means my 40.5 has to be less than mu value. That's what we are trying to understand here. Okay, so that means this is our 40.5 here, correct? Now let's try to say that this value here 40.5 minus mu upon root mu, let's try to write down with some letter z, that it will represent some value, correct? So let's say let z be equal to 40.5 minus mu divided by square root of mu. Okay, so for y this is 40.5. So when I plot the same graph for z, so this 40.5 will correspond to z here. Okay, this value as z when the mean will be 0 for a standard normal distribution curve. Okay, so what do we see here? We see is that this z is coming to the left of 0. So that means this z which we are going to get is negative. We are going to get it negative. Correct? This z is negative. So how do we find out this particular z? We also know in normal distribution that the areas are symmetrical. Okay, what do we mean by this? Areas are symmetrical. If I have to find out this probability of y greater than 40.5 or probability of z greater than this z value, it is as good as that I am supposed to find out probability of z less than, let me just write it here first, probability of z less than minus z. Okay, because this value will be exactly at the same distance as this z is from the mean. Okay, here. So I am supposed to find out this particular area here, this area and the area which we have put it on the curve here. These two areas will be same. Okay, so we are supposed to find out this particular area. Why we are taking the left side area? Why not the right side area? Because the standard normal distribution curve, as we know, gives the values only for the left area, not for the right area. Correct? So can I say that probability of z greater than this z value is as good as saying probability of z is less than this value minus z? Why minus z? Because here z is to the left of 0, so this is negative. So here to the right it should be positive, so that means it should be negative of this z here. Correct? So this value will be equal to what? 0.5793. Or in other words, can I say phi of minus z is equal to 0.5793? So if I have to get this z ka minus z ka value, so what I'll have to do? I will have to use the table in the reverse form, because they have given us the probability here. So we will use this probability to find out the value of z for which we are getting the probability as 0.5793. So we are going to find out phi inverse of 0.5793 using the normal distribution table. So this is our normal distribution table. If you see this normal distribution table, 0.5793 here is the value. This is the probability they have given. When we are getting this particular value, when the z is 0.20, correct? So that means when this particular value minus z is 0.20, this means this value of z is minus 0.2, and we had initially said that z is going to come negative, and we have got this negative value. Correct? Now what they are saying? They are saying that we have got this particular value z as minus 0.2. Correct? So this minus 0.2 has to be equal to this 40.5 minus mu upon square root of mu. Let's write it down. So therefore can I say 40.5 minus mu upon square root of mu is equal to minus 0.2. From this particular equation we are supposed to get the value of mu. So can I say this is 40.5 minus mu is equal to minus 0.2 root of mu, or in other words can I say mu minus 0.2 into root of mu minus 40.5 is equal to 0? Or in other words, can I say this root, this mu, can I write it as root mu whole square minus 0.2 into root mu minus of 40.5 is equal to 0? Now what has this equation become? This is nothing but a quadratic equation, correct? So if this is a quadratic equation, we can find out the value of mu using the quadratic formula. So can I say root of mu is equal to, I'll use the quadratic equation ka formula. What are the roots? X is equal to minus b plus or minus under root of b square minus 4ac upon 2a, correct? This is the root ka formula for a quadratic equation ax square plus bx plus c is equal to 0. So let's try to put that particular value here. So what I'll get? I'll get this as minus of minus 0.2 plus or minus inside the square root. Now I will have to put the values. So inside the square roots, what I'll get? I'll get this as minus 0.2 the whole square minus of 4 times a is 1 here into c. What is c here? C is minus 40.5 minus 40.5. Okay, let me just extend this square root sign. Okay, I'll extend this denominator sign also. So what do I get here? In the denominator, I'll get 2 times a, that is 2 times 1. Correct? So what will be this root mu ka value then? This root mu will be equal to minus of minus 0.2 is nothing but 0.2 plus or minus square root of. If I solve this inside the square root term, okay, what do I get? I get it as 162.04. Okay, divide by this whole thing, divide by 2. Now we know that this square root of 162.04 will be greater than 12 and less than 13. 12 ka square is 144 and 13 square is 169. So this value will be greater than 12 and less than 13. Correct? So that means this root mu, basically I'll have two values, 0.2 plus root of 162.04 divided by 2, or root mu will be equal to 0.2 minus of root of 162.04 divided by 2. But this value will be greater than 12, correct? So 0.2 minus this particular value will be a negative value. But square root of mu cannot be negative. So that means this value we will discard. This can't happen. The root of mu cannot be negative. So that means root of mu will be only this particular value. So what is this particular value we will get? Let's try to solve this. So if I solve this whole thing, okay, on the calculator, I get it as 6.4647 something something. So from this, if I have to get mu ka value, so I'll square both the sides. So what will be the mu ka value? Mu will be equal to 41.79.7929 something something, which in turn I can say is nothing but 41.8 in 3SF. Okay. So they had told us to find out the mu value. What is the mu ka value here? They told us to find out the mu ka value, and we have successfully found out that particular value. So with that, we end this particular question. Hope you have enjoyed the video. If you found the video useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.